Alright, I've been putting this off as long as I can. The quotient rule. Kind of nasty, and I would recommend that if you have a chance to get out of using the quotient rule by turning it into a product rule, we'll see some examples of that later on. But and I've already covered a few in the previous chapter of like algebraic ways to get out of it. However, there's just some situations where you have to do the quotient rule. Pretty much. I mean, like this example, to get out of the quotient rule, I could turn this into an x to the minus 2 times sine x. And honestly, I would recommend you do that because the quotient rule, I don't know, I just don't like it. But hey, there's other times, well, we could actually do the same thing here. The reason not to do it on this one, we could do x squared minus 1 to the negative 1 times x squared plus 1, but that's just trading one injury for another. Sure, the quotient rule is a bummer and creates a lot of extra math. It's just kind of a big nasty formula. On the other hand, this turned a quotient rule problem into a chain rule problem, because when I do the power rule on this term, I'll have to do the chain rule, and that's going to create the same difficulties that I was trying to avoid in the quotient rule. So it's kind of like out of the fire into the frying pan, or out of the frying pan into the fire is usually how it goes. But there are opportunities like this to where I think you actually will save a little bit of work by switching it to product rule. Just depends on what you like personally. I've actually met a few students who prefer the quotient rule to whatever other kind of trickery they can do. But again, you got to be really solid on algebra. You don't want to make a lot of mistakes. And you need to be a person who does not make any mistakes. So here we go. Now once again, just like with the product rule, we're going to label these u and v. So if you look at this quotient rule, you can see there's a lot of u's and v's and v primes and stuff. So I'm just going to label the top u and the bottom v. Now on this one it really does matter because we have a minus sign and stuff. So you see how the formula has u over v? We really do have to label the numerator u and the denominator v, and it's not interchangeable. Order matters. All right, so without further ado, plug and chug. It's going to be a giant fraction. First we put v, so that's x squared minus 1. Oops. And then multiply that by u prime. The derivative of x is just 1. Then we subtract u, which in this case is x, times v prime, which is just derivative of x squared minus 1 is just 2x. And downstairs, you read that right, it's just the original denominator squared. So x squared plus 1, oops, x squared minus 1. Now, you might be thinking to yourself, that's going to be a nasty foiling situation. To which I would tell you, you know what? Usually you're just going to leave it alone. The denominator in a quotient rule problem, you can almost always just leave it the way it is. So I would encourage you not to worry about oversimplifying everything and like just leave stuff nasty. If your teacher will let you leave it nasty, leave it nasty. All right, so x squared minus 1 minus 2x squared is the numerator, and the denominator is still, again, I'm not going to FOIL this out. Let's see, so that's just x squared minus 2x squared is negative x squared, so negative x squared minus 1, combining like terms, over x squared minus 1 squared. Oh my goodness. I'm actually not done. I happen to have come up with a problem where there is some reduction possible. So what I'm going to do is, see how we have an x squared minus 1 downstairs, and we have an x squared minus 1 upstairs? Oh wait, no, that's not going to work. I was thinking if we factored out a negative 1, we'd have a negative times x squared minus 1. That should be x squared plus 1, so hopefully I didn't confuse anyone. Yeah, we're done. My bad. You got to be careful. These quotient rule problems, man, they can mess with your head. All right, so once again, first step, u times v. So first I'll work this with quotient rule, and then maybe we'll try working it as a power rule problem and see if we get the same answer, or see if it was easier. So f prime is going to be v, which is x squared, times u prime, so the derivative of this. Then we subtract u, which is the numerator, times v prime, which will be derivative of the denominator, is 2x, all over x squared squared, which is x to the 4th. All right, so is there anything I can do with this? Not really. I mean, the only thing we could do is factor out an x from the top. So if we factor out an x, we get x times x cosine x minus 2 sine x. Because remember, I just factored out an x, so that's where this x went. All over x to the 4th. So this x will cancel one of these. So I'll end up with x cosine x minus 2 sine x all over x cubed. All right, so that's one answer. Let's try working it as a power rule problem, like I suggested on the beginning of this video. So we could rewrite this as x squared, x to the negative 2 times sine x. That's the same thing, algebraically identical. So label one of them u, label one v. So f prime, in this case, is going to be u, which is x to the minus 2, times derivative of v, which is cosine x. Then we're going to add v, which is sine x, times derivative of the other thing. So what's the derivative of x minus 2? It'll be negative 2, x, negative 3. All right, so far, you're probably thinking to yourself, man, this doesn't look a lot like the other answer we got. But I think algebraically what's going to happen is, because this other one's a fraction, I'll try doing that to this one too. So we'll make those two fractions. This first term will be cosine of x over x squared. And then this other one will be negative 2 sine x. And then that x to the minus 3 we're just going to put downstairs to be x cubed. Still doesn't look exactly like the answer we got the first time with the quotient rule, but it's getting closer, because if we wanted to make this a common denominator, we'd put an x right here and bump this up to a 3. And now you can see we have exactly the same answer. So the product rule, quotient rule, I don't know. We could argue about which one looks better, which one gave you a better answer quicker. I don't know, the quotient rule looks pretty good to me in this particular case, but hey, if you hate the quotient rule because you hate remembering which one comes first or whatever, you might want to stick with the product rule. Now the way I remember which one comes first, because you'll have to memorize this formula. So one trick is, or one problem that students have is, hey, how do I remember which thing comes first and which thing comes last? Well, the way I think about this is that it's just like the product rule, except there's a minus sign instead of a plus sign. And then the other thing, so that helps you get the sign right, but then how do you know which one comes first? Is it VU prime or UV prime that comes first? Well, the way I remember it is the denominator wins in the quotient rule. I feel like the denominator, it gets squared, which is great for it. It just got doubled or whatever. It just got, multiplied by itself. So there's a lot of v's in this formula. So the denominator wins. If the denominator wins, it also doesn't get subtracted. It does the subtracting. So that's why the denominator is going to be the one that doesn't get the derivative taken first. It's going to take away, it's going to stay itself, and it's going to take away the loser. Anyway, this might not be making sense to you, but that's the kind of way you want to be thinking about it. Try and come up with some little story or narrative you can think of about denominators versus numerators that'll help you memorize this formula. That's my advice. Or if you're really good at memorizing it, just memorize it. But anyway, that's how I did it. All right, so once again, we got a quotient rule opportunity here. So we'll label them U and V and plug and chug. Looks like f prime is going to equal v, which is square root of x plus 1. Now it's important to notice here, this 1 is not under the square root. It's just square root of x, stop, plus 1, times u prime, which can be 2x, minus u, which is x squared, times a derivative of v. So what is the derivative of v? Well, the derivative of that 1 is just nothing. The derivative of x root x, which is really x to the 1/2, right? So the derivative of x to the 1/2 is 1/2 x to the negative 1/2. And all that goes over v squared. So the original denominator squared. Which, once again, I would not encourage you to FOIL out. Man, I'm writing crooked. All right, so now we just got to FOIL this thing out. I assume your teacher would not accept this as a good answer. So we need to FOIL it out and combine stuff where we can. So we're going to get 2x root x plus 2x minus 1/2, and then x squared times x to the minus 1/2. We would just add the exponents and get x to the 3/2. All over the same old junk we're always doing, which is square root of x plus 1 squared. All right, so we're not actually done yet, because if you look real close, this is actually another x to 3/2 power. Because this is x root x is x to 3/2. So that means that this guy and this guy are like terms. So that's what we're going to do. 2x to the 3 halves minus 1 half to the 3 halves is going to give us 3 halves x to 3 halves, which I know is really confusing looking. And then we'll add 2x, and that'll all be over square root of x plus 1. Now perhaps you see some awesome way that you could reduce this, squared, but I do not, so I would just put a box around that, and worst case scenario, you lose 2 points or something if your teacher's a mega stickler for simplification, which, again, I don't know this can be simplified, but I know it would take long enough to find out that it's not worth doing. So, got to choose your battles in the AP class. Just figure if you get most of the problem right, use the right formula, you get most of the points. Better off to get a shot at another problem than wasting all your time trying to simplify one answer and not even get to the end of the test. All right, why don't we need the quotient rule? Well, this, as I mentioned before, best to avoid the quotient rule when you can. And what's going on here is that we can just convert this into a regular polynomial. The trick is, because the denominator is just a single x without any pluses or minuses or anything, we can just turn this into 3 separate fractions. X squared over x plus 3x over x minus 2 over x. And it might not look like the smartest move ever because this isn't totally beautiful, but this does turn into x plus 3 minus 2 times x to the negative 1. I just turned this into a negative exponent because, hey, you want to use the power rule, right? Whenever you see an x in the denominator like this, like in this term, to take the derivative, it's way easier if you just make that an x to the minus 1. Or if you had like 2 over x squared, that'd be 2 times x to the minus 2. But that makes it really easy to use the power rule. So once we have f of x in this form, now f prime is really easy to find, just one term at a time. The derivative of x is 1, derivative of 3 is 0, and then derivative of this last term is negative 2 times the old power, which is negative 1, times x to the new power, which is 1 less, so that's negative 2. If this phased you at all, go back to the previous chapter and check out the derivative of exponents, or the power rule, which is like where I went over this a bunch. We got lots of practice with that. So 1, these multiply together and become positive, so plus 2 x to the minus 2. And if you don't like the negative exponents, or your teacher doesn't, 2 over x squared. All right, that is that. Check this one out. Derive the derivative formula for tangent. Pretty sweet. Now, because we're in the quotient rule chapter, quotient rule video, you can bet that it probably involves a quotient rule. Let's take a look. So what I'm saying is this is the derivative of a tangent, secant squared. Let's see if we can figure out where this came from. So the trick is going to be that we're going to rewrite tangent as sine x over cosine x. Now it's a quotient rule problem. Here's u, here's v, and we can use the quotient rule. So I didn't write down the quotient rule on this page, but hey, the denominator wins. So we're going to do v first, which is cosine x, times the derivative of u, which is also cosine x. Then we got to subtract u, which is sine x, times the derivative of v, which is negative sine x. And all that is going to be over the original denominator squared. So cosine squared x. This simplifies to cosine squared x. Now there's the 2 minuses, so they cancel and we get plus sine squared all over cosine squared. Now this should definitely be ringing off your memory, ringing some bells in your memory from trigonometry. Cosine squared plus sine squared is 1. And this is the kind of crap, pardon my French, that you really need to notice and remember in calculus. If you're in an AP class and you don't remember those trig functions and those trig identities, and you don't study them now, you're going to miss some problems. It's not going to be a lot of problems. It's going to be like, I don't know, 10, 15% of the problems in this entire class are going to involve sines and cosines. It's a chunk. So you definitely want to go back and remember those. Anyway, so f prime equals 1 over cosine squared. 1 over cosine squared is actually secant squared. Because 1 over cosine squared would be 1 over cosine x times 1 over cosine x. And each of those is a secant x. And of course, secant x times secant x is secant squared x. And I apologize for my crooked writing today. I will try and rectify that before we get to the rest of calculus. All right, here's a few more where we don't need the quotient rule if we've got our thinking caps on. So why would you not need it for sine theta over tan theta? Well, just like in that last video, turning trig functions into sines and cosines is often a way to reduce them or get them to cancel out. So we could do the quotient rule on this, and by all means, if that's what you like doing, go for it. We're just going to see that sine theta and then tangent is sine theta over cosine theta. So even if you're not super sharp with your canceling rules in giant complex fractions like this, you should at least be looking at the signs wondering, I wonder if those cancel. So the way to figure that out is, remember that dividing by a fraction is the same thing as multiplying by the reciprocal. So sine theta is divided by sine theta over cosine theta, and then we'll just put over 1 on that sine theta to make it look more like a fraction. So that's division, which means that invert and multiply. So sine theta over 1 times cosine theta over sine theta. Sure enough, our sine thetas cross cancel and we get cosine theta. Now remember, this is not the answer. All we've done at this point is found a simpler way to write down f of x. But then of course f prime is just a derivative of that, which is real easy. It's negative sine theta. Because once we simplified it, there was no quotient rules, product rules, anything to worry about. It was just a flat out cosine, derivative cosine is negative sine. All right, this last one should be super obvious. Cosine squared over cosine, just subtract the exponents. It's just like if you have x squared over x, that just reduces to x because you sort of subtract the exponents. Same thing here, cosine squared over cosine just gives you a cosine. And once again, that's going to lead to an f prime equals negative sine theta. All right, and that's all we got for the quotient rule right now. As I mentioned before, the quotient rule with the chain rule, oh my gosh, there's a nasty booger, but that's what we're going to get into after the chain rule. So in the upcoming chapter, we'll do the chain rule, and then we'll revisit the quotient rule and the product rule, but with the chain rule instead. And it's just going to, it can get a lot messier. If you're in calculus, you may have already seen some super hard, complicated, crazy looking problems, and that's just how things go with the chain rule, unfortunately. But there's no class that does not do the chain rule. So don't even think that, even if you're in calculus for poets, you're still going to have to do the chain rule, I guarantee you. So stick around for that. And always look for ways to avoid the quotient rule is my personal motto I live by.